Okay. Okay, so you guys want to start here then? This part 4? Or actually, no, you said you want to start from.
Because when Dr. Mars, when I went to the lecture, she said we were starting with the pedigrees from that chapter.
Where is the pedigree? This right here, right?
Yeah.
Okay. Khan Academy. I should call it Majid Academy. Let's see. Okay, a pedigree describes interrelationships of generations, parents, and children. First generation. Okay, so um, does the idea of what's going on in this pedigree make sense? The males are squares, the females are circles. The lines in between show a marriage, and the lines coming down show kids. Does that make sense there?
Mm-hmm.
So here they actually go through and they actually write out. Can you see when I highlight here or no?
Yeah.
My mouse? Okay. So here they're actually going in and writing in what like the uh, genotype is for a given trait. So that makes it really easy. Like, okay, is it a dominant or recessive trait? Well, let's just look at, was it a large W or a small W? So it's easy there. But what makes it harder is when it's like this. Okay.
Yeah.
So now the same concepts apply though. A square is what? What does a square mean?
A male.
A square means a male and a circle means a female. If it's shaded, then that shows that that person has a positive a positive phenotype for that trait. Okay,
Okay.
so that means they show the trait. See how I'm being very specific, how they have a positive phenotype. I didn't say positive genotype. Okay,
Mm-hmm.
because let's look over here. See how this person has the phenotype for it,
Yeah.
but this person, because it's a recessive trait, right? See how this person has a recessive trait? They have the recessive gene right there.
Mm-hmm.
So they're carrying the allele for for that gene in their genotype, but they're not shaded because they don't express that phenotype. They're not
Okay.
expressing the result of it. They can carry it, but they're not expressing it. Okay, so that's important to know because this person could be carrying whatever like BS we're talking about, but this person not only is carrying it, but is also showing it, right?
Mm-hmm.
How do we know they're showing it? Because it's shaded. Okay.
Okay.
So if it's shaded, that means they're showing it. If they're not shaded, it means they're not showing it. Could they still be carrying it? It's possible. Okay. So that's why we need to do this pedigree analysis. Whenever we're looking at this pedigree analysis, let's see here. Let's see. Whenever we're looking at this pedigree analysis, it's not just enough to look at just one of these things over here, okay? Like we can't just look at one section. If we just look at one section, we're not going to have enough information to be able to answer, is it autosomal recessive? Is it autosomal dominant? We don't have enough information. That's why we need to look at multiple generations of it, okay? And that's why they give us the second generation, the kids. What happened from the kids, okay? And that's why they also give us a third generation, so we can figure out what happened to their kids. Okay?
Okay.
Does that make sense? Why we're looking at multiple levels of this?
Mm-hmm. So
Because
like
one
it's different generations, right?
different generations. So this is like the grandparents, These are the kids, and then these are the grandkids, okay?
Okay.
Now, if we just looked at one, we don't have enough information to be able to answer these questions. If we look at a second, we have more information, but still not enough. By looking at a third generation, now we have enough information to make some guesses, okay?
Okay.
So whenever we're doing this, the easiest way to start is by looking at, is it X-linked recessive, okay? That's the easiest one to know, okay? Or sex-linked is usually the easiest one to know. Not always, but that's typically how I start, okay? Or how I would start, at least as of right now. As we do more, I may change my mind, but I'm pretty sure that's how I would start, okay? Why
Okay.
start with X-linked? Because we know that squares are males, so they have to be X, Y, right?
Yeah.
And these guys right here have to be X, X, okay?
Mm.
So the that's why I think starting with X-linked, sex-linked is going to be the easiest. Now, let's say it's X-linked recessive, okay?
Okay.
So now it's kind of just playing through the different scenarios, okay? So if this is X-linked recessive, the way we're going to show it is we're going to show X little a, and we can also have X big A. Okay, that's how we're going to show it. Okay,
Okay.
that's how we're going to show the sex-linked alleles. Does that make sense?
Yeah.
It's just like when we have a normal A and a little a, but here instead we're attaching it onto the X to show that they're sex-linked.
Okay.
Does that make sense?
Yeah.
Why am I going through and adding it onto X, um, on specifically onto X? Because they asked us, is it X-linked recessive? Okay. So right now we're saying let's hypothetically assume that it is X-linked recessive. If it is X-linked recessive, um, what does that mean? Would this be X big A, X big A, X little a, X little a, X little a, X big A? What would I label this as? This person right here.
Would it be X and little a?
Um, let X little a here. And then what should I put here?
Little a?
Exactly. Can you tell me why?
Because it's recessive.
Recessive. And for something recessive, and it's showing in this person, right? Because they're shaded.
Yeah.
So for it to be recessive, for it to show, that means that I need both of them to be recessive, right?
Yeah.
If I had even one dominant one, then this wouldn't be shaded in black anymore, right?
Mm-hmm.
Okay, so we established that. Good. Now, let me just redraw that because I didn't like the way that looked. That doesn't look much better, but anyways, what can you tell me about this, the husband's ex? Again, we're just for the sake of argument, assuming that this is X-linked recessive. What can we say about this X? Is it X little a or X big A?
Little a?
Little a. Okay. Why would it be little a?
Because X linked recessive.
Okay. But are they showing it?
Yeah. Because
How are
they're
they showing
shaded.
it? We said they're showing it if they're only showing it if they're shaded, right?
Yeah.
Is this person shaded?
No.
That means they're not showing it, right?
Mm-hmm.
So now, again, we're assuming that if they're showing it, it's because it's X-linked recessive, right?
Yeah.
So they're not showing it. So that means they can't be recessive because they only have one version of X. So if they had little a
Okay.
here, then they would be shaded in. You see that?
Yeah.
You see what I mean, or are you just saying yeah?
No, yeah, I see what you mean.
You promise?
Yeah.
Because your mom's gonna beat me up if she thinks that like I didn't sh I didn't show you this properly.
So
Yep,
like
I will beat you up. Just kidding.
See? No,
So
no,
when it's
I
not
have you
shaded as
recorded
A.
as threatening me. So
Oh my God, I'm so sorry. I
if
forgot.
if anything happens to me, I'm gonna
It was
take
a
this to the
joke.
no, I'm taking this to the police, and they can look for my dead body.
Oh my gosh, it's a joke.
Okay. So this should be big A, right, Bridget?
Yeah.
Does it make sense why?
So when it's not shaded in, it's a big A. It's like
Not. So I don't want you to think when it's not shaded, it's a big A.
no,
What I
a
want,
dominant.
right? Why is it dominant? Because we said let's assume it's recessive, okay?
Hmm.
Because that's what they asked. They asked, is this autosomal recessive, autosomal dominant, X-linked recessive? But they could have easily asked me, is this X-linked dominant? Okay.
Yeah.
And then if they ask me, is this X-linked dominant? Then I have to say, well, this could be X big A, X little a, or X big A, big A. Because if it's X-linked dominant, all I need is one big A to show, to be present, for it to show in this person. Does that make sense?
Yeah.
Are you sure?
Yeah.
Because this is an important idea. If you want me to say it again, I can say it again.
Yeah, you can go ahead.
Go ahead and keep going, or go ahead and say it
No,
again.
like you can repeat it.
So again, the reason, what I need you to first understand is that if it's dark, it's because that person is showing the trait. Okay. So let's go back to some basics. Okay. If um let's even give it some more concreteness. Okay. Let's say that this is for I don't know, let's call it red hair color. Okay.
Okay.
So this person, is this person showing red hair color? Or, and then the other option would be black hair color. Okay. Is this person showing red hair color or black hair color?
It's showing.
It's showing, right? Does this person have red hair or black hair?
I don't know.
So here's how you know, because right now, whatever gene we're talking about, again, if it's if the person is black on the pedigree analysis, it means they're showing that trait. Okay. If they're not shaded in, it means they're not showing that trait. Okay.
Hmm.
So just for the sake of the example, I'm saying the trait we're talking about is red hair. Okay.
Yeah.
So anybody that's shaded means they have red hair. Okay. And if they're not shaded in, it means they're not showing red hair. Okay. It means they're showing black hair or whatever the other trait could be.
Okay.
Okay. Like remember how we said, just like how we did with all the other stuff, like up here. Oh man, that stuff travels with me. Just like how we said in all the other stuff with the genes up here, right?
Hmm.
It's the exact same thing as like these Punnett squares right here. Um, mm, like purple and yellow,
Yeah.
you know, if it's big P, they're purple. If they're big P, little p, they're purple. But if they're little p, they're white,
Yeah.
right? So same thing. I'm just making one be red hair and one be black hair, for
Black.
instance. Okay.
Okay.
So it's the exact same idea. Okay. It's just we're looking at it from a different way. We're looking at it in the generational analysis. Okay. So let's come back here. Now, we said if they're shaded in, that means they're showing that trait. Okay.
Hmm.
So like in the example above, if the flowers are showing the flower color, they're purple. If they're not showing the flower color, they're white. Okay. Does that make sense?
Yeah.
Um, I guess maybe that's what's tripping you up. So in that example, you could have purple or white, right? They're both showing a color, but what we're saying is that um, one of them we're assigning like a positive value to, and one of them we're assigning a value we don't care. Okay. So we care about purple, we don't care about white. So right now we're just trying to see which plant is showing up purple, which person is showing up with red hair. Okay. The other one, yeah, they still have a color here. It's not like they don't have a color, but all we're concerned about is the red hair, them showing the red hair trait. Does that make sense?
Yeah.
Okay. So if they're shaded in, what does that mean? Are they showing it or are they not showing it?
They are showing it.
They are showing it. Okay. So this person is showing it. Is this person showing it?
No.
Oh, whoops. Uh, 1 second. Okay. So this person is showing it, right?
Yeah.
Is this person showing it?
No.
No. Good. They're not showing red hair. Now, from their kids, is this kid showing red hair or no?
No.
No. Is this one showing red hair?
Yeah.
Yes. Okay. Now, from all these kids, is this one showing red hair?
Yeah.
Why?
Because it's shaded in.
Good, because they're shaded. How about this one?
It's shaded, so it's showing right here.
Okay. You see that?
Yeah.
Now, what do we say? Squares are
Males.
males. Circles are
Females.
females. Good. That's going to be something important to remember, okay? Because that's pretty universal. Pretty universal throughout. Like if you see here, square is male and circle is female, okay?
Okay.
So I need you to keep that in mind because when we go to look for X length and all that, that's going to make a difference, okay?
Okay.
Okay. So we said not shaded doesn't show it, okay?
Mm-hmm.
Now, based off of that, they want us to, they're trying to ask us, um, can we figure out is this recessive or dominant, and is it sex-linked or not sex-linked? Okay, so they're giving us 3 options. Okay, they're asking us the trait found in the individuals is represented by the shaded symbols. Which of the following patterns of transmission for this gene are consistent with this pedigree? So they're asking, is it possible that this red hair is an autosomal recessive trait? I don't know. We need to examine it. Is it possible for it to be autosomal dominant? We have to check. Is it possible for it to be X-linked recessive? Well, let's check. Okay. And the quickest way not the quickest way, but the least confusing way to figure it out is let's just assign it. Okay. Let's
Okay.
just assign it. So let's just assume this person is showing it, right?
Mm-hmm.
They're asking, can this be X-linked recessive? So let's just assume that this person is X-linked recessive. Okay. Now we have to go in and see, okay, if this person is X-linked recessive, does it make sense that this person could be still showing that trait? And if that's true, can this person still be showing that trait? Can this person still be showing that trait? Like all these should make sense if it's X-linked recessive. We shouldn't find any inconsistency in the genotypes that we see. Okay.
Okay.
So let's just run through this real quick. Okay. Maybe once I do one, you'll see what I mean. So X-linked recessive means that it's X little a, X.
Yeah.
It means that X little a is there, right? There
Mm-hmm.
cannot be an X big A,
Okay.
right?
Yeah.
It can't be this. Does that make sense why?
Yeah.
Because if that dominant thing was there, then that would take over and the trait wouldn't show. Okay?
Yeah.
So this is a female. Females have 1X or 2X's?
2.
2. Okay. X, X. Now, if it's X-linked recessive, we said only little a can show up, right?
Mm-hmm.
So this person has to be X little a, X little a. Does that make sense?
Yeah.
Now, this is a male, right?
Mm-hmm.
Males are X, X. YY, XY, what are they?
XY.
XY. Good. Now, we said that this is X-linked recessive. So does Y matter as far as this trait goes?
No.
Okay, so we don't need to figure that out. We just need to figure out, is this going to be X little a or big A? Okay. Now, does this person show the trait?
No.
No. So if this trait was X-linked recessive, we can't have any X big A's, right?
Yeah.
Because if there's an X big A and you show the trait when it's recessive, if there's a big A, I wouldn't show the trait. Does that make sense?
Mm-hmm.
What I just said?
Yeah. I'm confused because like at first I thought if it was shaded, it would be like big A or something like that. And then if it
No, no.
wasn't,
So that's the thing. That's what I need you to break out of. Because just because it's shaded doesn't mean it's dominant.
because
It
like
just-
that's what Dr. Mars put on here, and that's why I was confused.
So for the
That's
for
what
the
I
first
thought too.
Because she drew it. I have it written from what she put. And she put that like the black was big P, little p, and then the square that wasn't shaded was little p, little p.
um I don't know why you guys always want to say I'm wrong, but okay.
We don't want to say you're wrong.
No,
I'm just confused.
no, that's fine. Just listen to what I have to say, okay? Give me 1 second. I'm showing you how to figure it out always, okay? So this is gonna show when this is gonna be shaded when the trait shows. Does that make sense?
Yeah.
Now, right now, we're just assuming for the sake of argument, because they're asking, can this be X-linked recessive? So we're trying to say, okay, let's just assume it's X-linked recessive. It's going to show when I have X little a little a. I can't have any big A's. Because if I have a big A, it's going to show. It's not going to show, right? Because we're assuming that it's X-linked recessive for right now, right?
Mm-hmm.
So this is going to be X big A, okay?
Okay.
It's X big A because this person has an X, but they're not showing the trait. And we said to show the trait, it's X-linked recessive. Okay? So now this person, this daughter, right? This is a female, right?
Yeah.
So this female is going to get one X from here and one X from here, right?
Mm-hmm.
So if she's the only X this dad has to give is this one right here, right?
Yeah.
The only X he has is a big AX, right? An X big A,
Yeah.
right? And we said if you have X big A, the trait is not going to show, right?
Yeah.
Is the trait showing in her?
Yeah.
So then we know that this pedigree cannot be an X-linked recessive trait.
Okay.
Does that make sense what I just did?
Yeah.
We just broke it down. We're basically saying, oh, okay, you're trying to tell me it's X-linked recessive. Let's assume it's X-linked recessive. The first time I'm able to go through this and find that it doesn't make sense anymore, I'm able to break that pattern. That means that it can't be this anymore. This is impossible. Okay?
Okay.
Because one of your X's for this girl is going to come from the mom, one is going to come from the dad. The
Mm-hmm.
dad only has a big X, big A, and X big A to give. And if there's even in order for the trait to show, if it's X-linked recessive, there can't be any big A's present. But here he can only give a big A. This girl has to have, unless there's a different dad, but then we're not talking about the same pedigree. We're talking about some like weird Jerry Springer stuff, okay? So that's why this has to be a big A. And if that's true, then this she wouldn't be showing the trait, but she is. So that's how we know that it can't be X-linked recessive. Okay?
Okay.
So we're kind of going through and eliminating each one of these. Okay? So now we look at, okay, is it autosomal recessive? Okay? So if it's autosomal recessive, and our time is going to end in 5 minutes here. But if it's autosomal recessive, that means it's going to be little a, and this person can be either big A, little a, or
Oh, okay. I think I know what you're doing now.
yeah, I'm
Yeah,
basically
I
just
get it.
playing all the different scenarios,
Yeah.
right? So now let's assume that this guy right here is big A, little a, okay?
Mm-hmm.
So now, is it possible for this person to be little a, little a? Do you see why this person has to be little a for this to work?
Mm-hmm.
Yeah, what's up, Liz?
No, I just wanted to do that. Okay, sorry.
So, it makes sense why this person has to be little a, right? Because
Mm-hmm.
right now we're checking, is it autosomal recessive, right?
Yeah.
So if it's autosomal recessive, that means that I can't have a dominant allele. If there's a dominant allele and it's a recessive trait, the recessive trait won't show if there's any dominant alleles present, right?
Yeah.
So if this person is showing it, this person has to be AA. And this person can be either big A, little a, or big A, big A. Okay.
Mm-hmm.
So right now we kind of put this guy off to the side. We're not worried about him right now.
Yeah.
Okay. We're trying to figure out first with this guy over here. Okay. Is it possible that she can just give one little a over here? Is that possible? Yeah, that's the only thing she can give. All she has is little a's. This guy has one big A and one little a to give. Is it possible for him to only give a little a here?
No,
Why?
because he's dominant.
He's dominant. But again, remember, just because you're dominant doesn't mean you only pass off your dominant allele. Because when he goes under uh, meiosis, he can give any combination of those alleles. He's gonna, whenever he's giving off this trait, remember, he's gonna form 4 cells, right?
Yeah.
He's gonna have 4 haploid cells. One's gonna have big A, little a, right? So just because he has a dominant one doesn't mean that he has to pass off the dominant one. He doesn't always pass off the dominant. It's 50-50 whether he's going to pass it or not, right? It's possible for him, even though he has the dominant allele, he could just give off the small allele, the recessive allele,
Yeah.
right? Does that make sense?
Yeah.
And it's possible that he gave this one the small one and he gave this one the big one. And that's why this person ended up big A, little a. Okay? Does that make sense?
Yeah.
So now this person right here is um whatchamacallit? Um showing, right? So this person has to be little a, right?
Yeah.
If it's autosomal recessive, they have to be little a. That's the only way they'll show it, right?
Yeah.
So the only alleles this guy can give is little a. The only alleles this girl can give are little a's, right?
Mm-hmm.
So how the hell did this guy come out with a big A? Because he has to have at least one big A for to not show, right?
Yeah.
So where did that big A come from? We don't know. We can't explain it. That's why it can't be autosomal recessive. We knocked that possibility out.
Okay.
And so now we don't even have to go and figure out how is it autosomal dominant. We just automatically know because we knocked this choice out, we knocked this choice out. It can only be this one. Does that make sense?
Yeah.
Are you sure what I just did make sense?
Yeah.
We basically did this. We basically said, okay, let's hypothetically say it's X-linked recessive. Let's see if it makes sense to have these types of kids based off of that. It doesn't make sense. You can't have those kind of kids if it's X-linked recessive. So it's not X-linked recessive. Is it autosomal recessive? You can't have those kids if it's autosomal recessive. So it's not autosomal recessive. So our only choice is it's autosomal dominant.
Okay.
Does that make sense?
Yeah, I got it.
This is going to show up on the next exam.
Mm-hmm.
The meeting is going to end. I'm going to start a new recording.